question 3. Question 3, part A, is differentiate y equals to 4x cosec of x. And this is a product of two functions, the first one being 4x, the second one being cosec x. So using product rule, the derivative is the derivative of the first function, which is 4 times the second function, cosec x, plus the first function times the derivative of the second function, which is negative cosec x cotangent x. And you don't need to simplify, so you can just leave it like that. Okay, part B. Find the equation of the tangent, so y equals mx plus c, to the curve y equals 4x over sine x at the point x equals pi over 2. So we want the y equals mx plus c at this point. So we want the gradient and we want the c value. And so in order to find the c value, we need the coordinates of at least one of them. And we've only been given of a x value. So we need to just solve for the corresponding y value as well. So y is equal to 4 times pi over 2 over sine of pi over 2. And what is sine pi over 2? Sine of pi over 2 is just 1. So this is simply, so 4 divided by 2 gives us just 2. And it's divided by 1, so it's just 2 pi. So our coordinates is pi over 2 and then 2 pi. Okay, now what about the derivative function? Or the gradient function? Well, it's a quotient between two functions, so you're going to use the quotient rule. So it's the derivative of the top function multiplied by the bottom function minus the top function multiplied by the derivative of the bottom function divided by the bottom function squared. So all in all, this gives us 4 sine x. Sorry, sine just differentiates to cosine, not negative cosine. And then minus 4x cosine x over sine squared x. And we're interested in the gradient, so let x equals pi over 2 to solve for that gradient. So this is 4 sine of pi over 2 minus 4 times pi over 2 times cosine of pi over 2 over sine of pi over 2 squared. And cosine of pi over 2 should be 0. It is 0. So all of this just goes to 0. And then sine pi over 2 we know is just 1. So all of this, well, this just turns into 1, and this just turns into 1. So all we're left with is just 4. Okay, so now we know the gradient and we know 1 point. So we can use the equation that we did before, y minus y1 equals equal to m times x minus x1 to solve for the equation of the tangent. So y minus 2 pi, using our points, is equal to m was 4, times x, and the x1, the coordinate is pi over 2. So then expanding the right side is 4x minus 2 pi. And you can see they got negative 2 pi on both sides, so y is equal to 4x because they both cancel each other out. And that is my equation. Okay, and then part C I did skip, so I just don't want to do that. So I'm just going to leave it like that. But let's move on to part D. Part D is for a curve defined by a parametric equation, x equals 4 over t, then y equals 2t squared plus 5t. First part I, is find the equation of the tangent at t is equal to 2. So again, you need to find the equation of that tangent y equals mx plus c at point t is equal to 2. So again, if you need y equals mx plus c, you need the gradient, so you need to find dy over dx parametrically. And to solve for c, you need to know at least 1 point along this curve. And so to find your coordinates, to solve for x, y, the x component is 4 over t, and then when x equals 2, we're interested in when x equals 2. So this is just 4 over 2, which is equal to 2. So that's the x component. The y component is 2t squared plus 5t. So again, let x equals 2. So this is 2 times 2 squared plus 5 times 2. 2 squared is 4 times 8, times 2 is 8, and then plus 10, that gives us 18. So xy coordinates is 2 and 18. And then for our gradient, we want dy over dx, but it's parametrically, so you need to find dy over dt, and then multiply that by dt over dx. So if x equals 4 over t, this is the same as 4 times t to the negative 1. So then dx over dt is equal to negative 4 t to the negative 2, or negative 4 over t squared. And then again, we're interested in when t is equal to 2. So we can substitute in t is equal to 2. So it's negative 4 over 2 squared, which is negative 4 over 4, which just gives us negative 1. And then for our y is equal to 2t squared plus 5t. So dy over dt is equal to 4t plus 5. And again, let t is equal to 2. So then dy over dt at this point is equal to 9. And since dx over dt is equal to negative 1, the reciprocal of negative 1 is just still negative 1. So then dt over dx is also equal to negative 1 at this point. So then overall, dy over dx is equal to 9 times negative 1, which equals to negative 9. So that's the gradient to that point. And then using the equation that we used before, y minus y1 is equal to m times x minus x1. Y minus the coordinate of y, which we know is 18, is equal to m, which we know is negative 9, times x1. The coordinate is going to be 2. Yep, it was 2. So then expanding out the right side is negative 9x and then plus 18. And then I can move the negative 18 over to the other side to give us positive 18. So it gives us negative 9x plus 36. And that is my tangent equation. Okay, and the second part is find the values of t where the curve is concave down. Where the curve is concave down, this means that the second derivative is less than 0. So we need to find the second derivative here, which we can calculate by using the general formula. So it's the derivative with respect to t of the first derivative we've just found, and then multiply that by dt over dx. We already know dt over dx. This one was equal to negative 4 over t squared. So we just need to derive the dy over dx function. So dy over dx was given by dy over dt times dt over dx. So that would be dy over dt times dt over dx. dy over dt we saw as 4t plus 5. And then dt over dx is going to be the reciprocal of this expression here. So that's going to be t squared over negative 4. So t squared over negative 4. So then this gives us 4t cubed plus 5t squared over negative 4. So then deriving this function with respect to t is going to give us 12t squared plus 10t over negative 4. Okay, and so then we need to multiply this by dt over dx. So then d squared y over dx squared is equal to 12t squared plus 10t over negative 4 multiplied by negative 4 over t squared. Sorry, it should be t squared over negative 4. Should be the reciprocal of that. T squared over negative 4. Okay, so then this gives us 12t to the power 4 plus 10t cubed over negative 4 times negative 4 just gives us positive 16. And we need to set this equal to 0 to solve for our t intercepts. So this is t cubed times 12t plus 10 equals to 0. So our intercepts are t is equal to 0 or t is equal to negative 10 over 12, which you can simplify as negative 5 over 6. Okay, so what does this function actually look like when you graph it? Well, it's a quartic, that's t, and this is the second derivative. And it intercepts at 0, and then negative, so this is at 0, and then negative 5 over 6. And it's a quartic, and specifically it's a positive quartic because the coefficient of t to the power 4 is positive. So it's going to follow the general look like this with these intercepts. And it intersects, so what does that look like? So if you just draw it, it might look like this. Maybe, something like that. But essentially, when is this concave down? So when is it less than 0? when is the second derivative less than 0? And if it's less than 0, then it's below the x-axis, which occurs between these points over here. So that is between negative 5 over 6 and 0. So it is between negative 5 over 6 and 0. And that is when the function is concave down. And yeah, I think that's it. Oh yeah, that is it. Okay. So that is my answer to these questions for the differentiation paper. Yeah, I hope it helped to watch this over. Any questions, again, just message me if you need. Okay, that's it. Bye.